looks like 1 kilometer there. Okay, so say if I went from like right there to, nobody can see that, can they? Is that green? Do we have black? And then you would draw in the opposite of your Louisville jet, which is southwest at 45 knots. So if I'm at 50 here, just saying, it would be like here, and then there would be your Corfiti vectors. But I don't know. This is labeled in heights. It's not labeled, or it's in kilometers, of course. It's not labeled in pressure.
So if your low-level jet was actually from the northwest, then you.
Yeah. Yeah. So if your low-level jet was blowing to the northwest, the opposite of that would be like that.
Okay.
So the first vector you drew, is that literally just connecting like 850 to 300?
Well,
more or less.
More or less. It's the mean wind in that layer. So it's called your propagation vector. Or your vector, I'm sorry. I apologize. I got that backwards. But yeah, it's basically the mean wind between those two layers. It's not the bulk wind difference, which is basically what I just drew, but where's the eraser? Remember, when you're drawing your mean wind, you generally break it up into U and V components. And you know what this might be? This might be your upwind propagation and your down, the UP and the DP. Alex, did you ask that? That might be your Corfiti vectors actually drawn on there.
That would make sense, though. I mean, if you extended yours out a little more.
Yeah, it says down in Corfiti actually.
Yeah. Oh, there you go. You could just look at the sounding too. If I give you this exact sounding and you guys draw it perfectly like, I'll be like, how did they figure that out? But I'm sure I'm not exactly right on my mean wind here, and I'm not, because of that, I'm not exactly correct on my opposite of the Louisville jet, which I think would be the negative of around 45 knots. And so, yeah. I hope that helps, though, in the general idea of how to draw the Corfiti vectors. There's two vectors. One's the effective, and one's the propagation. Propagation is the negative of your Louisville jet, and you would look on your sounding at your Louisville jet. The hard one is the 850 to 300 millibar mean wind, which is what we would of course give you, because that's kind of hard to estimate on a photograph without knowing what it is. I mean, I think this is the mean wind, but I think that's 0 to 6 mean wind is the box, 217 at 45.
So your first arrow that you drew was from 850 to yours, what?
Well, I drew it from where I thought maybe somewhere around 850 to somewhere around 6 kilometers, but that's not, that's really drawing in the bulk wind difference. And so it's really not, it's not perfect. Obviously it's not perfect because I think this is the up shear Corfiti vector down there.
And so what are you drawing back to?
Here?
Yeah.
That's the negative of the Louisville jet there. So that's your that's your propagation, which is the negative of the Louisville jet. This is your effective. Wish I was talking. Wish I was above. Which is the 850. The mean wind is 850 to 300 millibars.
You said that you'd probably be given the.
Yeah. Yeah, you'd be given the mean wind and the Louisville jet. Basically, what I would want you to know is not how to compute those things, but how to get the Corfiti vectors from those things.
So we're gonna have to, so we'll draw the Corfiti vector, but we won't have to like give you the magnitude of the Corfiti vector like exactly.
Well, no, I guess not really, but you know, your say this was your Corfiti vector, so it would be like this, and so the magnitude of your Corfiti vector would be, you know, around 10 knots. So I won't ask that though, but if you wanted to estimate that, you could. Like, I think it's actually 276 at 19.
So yeah, the UP.
Yeah, so this has to be it. Yeah, 19, 276 at 19. So where I messed up, and I guess I did mess up, but is it's hard to draw your effective 850 to 300 millibar mean wind without some use of a plotting program. So we'll certainly give you that if that makes it clear.
So would you give us that, like they have it down there with the direction and the speed, or would you like plot the vector for us, for the mean wind?
I would not plot the vector. You would plot the vector. I would give you a photograph that looks like this, okay? And then I would say the mean wind is the mean wind between 850 and 300 millibars is I don't know, 276 at 50 knots or something like that. So that you would be able to find where the mean wind is.
Okay, so just like it's written down there, and then
Yeah.
we would plot it?
Yeah.
Okay.
So for the Corfiti downshear, so that's your effective from your 850 to 300 millibar then? For like, where it says Corfiti downshear, so you go from where that 850 is down, or whatever way, you know, 231 is, or whatever it is, to like about the knots that it should be at, or the speed that it should be at.
I think I follow you. I think I do. And
So I'm just asking if the Corfiti downshear is the same thing as the effective 850 to 300.
yes.
Okay.
Yes. And so the example on here is you still have that. This is this board still keeps freaking me out. So this is still your mean cloud layer wind. So still your advective here, and you're still then you're still using the negative of your Louisville jet here, even in the progressive. And then you figure out your original forecast storm motion, and then you add that original forecast MCS motion onto your advective up here, which gives you this here, and then your progressive is this vector here. Does that make sense?
This is for the updated version of
Yes,
Corfiti.
exactly.
Okay, so can we go back to the example?
Yeah,
and then
absolutely.
put our progressive one on there then?
Yep. So, so using my example and not the actual, the real one, because it's already written on there. So we have our effective here, right? I'm gonna sneeze. No. I said I was gonna sneeze, so I didn't sneeze. So okay, so here we go. We have our effective 850. Just say this is. It's not correct, but say the 850 to 300 millibar wind vector is here. The mean wind is here, right? And so the Corfiti vector, that the original Corfiti vector is this. Let's just do this. Corfiti, that's an F. Corfiti original, right? And so that's that vector. So this vector would then be added on to your mean wind, which is here. So it would be like this. And then your progressive would be like that, which is not right, given that sounding. But given the example that I originally started to draw, it's right. Are you recording?
Yeah, is that weird?
Yeah.
I can delete it if you want me to.
I don't think I've showered in a week.
Well, don't worry, you're hardly in it. I mostly zoomed in on
good.
the
Yeah.
on the.
You have not got my good side.
So the
I like to have a
progressive one,
haircut.
they haven't plotted the progressive one on there.
Yeah, they did. It's
They did.
it's the down shear. This
Oh,
one here.
okay.
Yeah. It's 231 at 57. My example, I feel bad because my example is wrong. And so we're trying to use my example while their correct example is already up there. What would probably be better is if I got rid of that sounding, drew my own sounding, and then did one like that. But the key component is that mean cloud layer between 850 and 300 millibars. Getting that, and you take that from your MCS motion.
Okay.
I think those are really good questions, and I'm glad you asked that to clarify those. I don't fully think I've done it justice there, but so let's do this. Let's maybe make it better. So because I don't want anybody to misunderstand what I'm doing. So you have your MCS right here, right? This is your MCS. It's very small, but it's very mighty. Very severe. It's bad. You're sitting in a forecast office. You want to know where that MCS right there is going to go, and so you would then take from this where your current storm is, and you would draw in your 850 to 300 millibar mean wind. Say it's like this, right? And then your low-level jet is like the negative of your low-level jet. Maybe you have a really strong low-level jet is like this. And then so your Corfiti vector would be like that. And that is your upwind or your original Corfiti vector. So you would expect your MCS motion to go like that.
And so then we could do the progressive one off of this.
Yeah, we can. So taking that same exact situation where you have this very tiny but very severe MCS, and drawing the exact same things where you have your 850 to 300 millibar mean wind, and then you have this really strong low-level jet. So the progressive one's very similar. So you have this same thing, and this is your original or your back building Corfiti, but instead you're adding that onto this, which is your 850 to 300 millibar mean wind, which goes like this then, and then your progressive one would be like this, and this is your progressive.
So what does our progressive exactly tell us again?
That's a good question. So I wish I had that presentation, but when, say in a situation where your cold pool is not, or your cold pool is stronger than the ambient horizontal vorticity, and you're going to have outflow dominant storms where your outflow is going to surge out ahead. This vector here should give you an idea of the speed at which that direction, or the speed at which that MCS is going to propagate downstream. Now, in an MCS type situation, like it could be, here again is our little but very mighty MCS, and then at a later time, it produces this outflow, which looks like this. So your MCS is in here, but the outflow is there. At some later time, the outflow is way out here, and your MCS is right here. So it's supposed to, and it does a pretty good job, forecast the speed at which this this system, the forward propagating part of it, accelerates in whatever direction in this situation to the southeast. Now, what's interesting here, and I might complicate things unnecessarily, but on the say on this side where you have your outflow, you might still get regeneration of thunderstorms along the outflow on the south side, where you would need your original Corfiti vectors, because you could still get back-building storms in this area that track down to the southeast as well. But what the progressive Corfiti vectors, or the down shear Corfiti vectors, are supposed to give you is how fast and to what direction the outflow basically is going to head out.
So for a very large MCS, let's say it's like a very large one, does it do well still with the whole MCS, or is
No,
it only individual cells for?
It doesn't do well with the individual cells. What it does well with is the gust front, is the cold pool, the movement of the cold pool. That's a great question. The movement of the cold pool is what it really does well at. Movement of the individual cells, or like these cells here, or this boundary, which is the outflow left behind, it does not do well at. But the progressive, or the down shear one, does do well at determining the speed of the cold pool. These are great questions. I have a feeling I'm going to find this video online someday, and it'll be edited. And
I promise you're not in it.
I'll be wearing a tutu or something. Other questions?
I have one, but not about this. I guess if we're ready to switch gears, or if we can.
Yeah, yeah.
I just wanted to maybe see another example, or even the one that you guys have on the review slides of like the effective bulk wind difference, like the layer.
Yeah, let's do that.